Okay. Um, so girls, okay, by March 2nd, you know me well enough for those to be very strange words. Like if you felt like you didn't do well on the quiz, then see me and blah, blah, blah. That's really a weird, you're like probably looking at me like, who has taken our teacher and replaced us with someone reasonable? Because I'm usually like, oh, well, let's keep moving. Oh, well, he would be more unreasonable than me, most likely. I don't know. Anyway, those words have never come out of my mouth, but I felt like during the quiz, it more flagged things that I needed to say to you more clearly, more than, as like I can't go, well, y'all weren't ready for the quiz, and too bad, and I'll give you whatever grade you deserve, which is normally not the words that will come out of my mouth, but it's actually what I really do and believe because I don't want to be too nice or too easy. Um, anyway, I felt like with the questions that the class as a whole were asking, that I felt like it was more instead of me pointing my finger at you, that there were three fingers pointing back at me. Like, did I really say these words to y'all, and is everything okay? And depending on what you focused on lately, how much you understood what I was trying to say, probably for the end of last week. So, if after I go over the questions to the quiz and you get a chance to ask, what if I did this, what if I did that, and it's good exam review, and it's also great preparation for AP Calculus, so that's, I care more that you know the material right now as a class. Anyway, if you felt like that you made 100 and you are good to go, that's fine. You don't need anything else on your plate this week. But if you felt like you did really poorly on the quiz, I could give you some like a Delta math quiz on it, or retake it, or make up some different numbers or something. Let's just cross that bridge when we come to it, okay? Um, the words we have said, converge and diverge. There's that whole, in fact, if you go to my, I don't think it's on my honors pre-calc page, but you have no reason yet to go to my calculus page. Some of you will one day, but actually, under topics for series, I actually used the poster from Divergent from the movie and the book. Yeah. So, we really mean is divergent. Divergent, I tell you when we talked about it, is we talked about if something's happening in Marymount and we've got a talent show. Then we saw all of the girls, all of our students were converging on the auditorium, weren't they? So that was convergent. Normally, at that time of day, we're divergent. Aren't we all going to different places, clubs, might even be at 97th Street coming over from PE or whatever. Do y'all see what I mean?
Yeah.
Okay, so lots of things in the world are divergent. I think I also use the example of when you hear ambulances and police cars, a lot of times they're converging onto an apartment building. Or if something happened in the city, God forbid, we would hear things. Right now, you might see something going this way and something going this way, ambulance going that way. But if something big happened, wouldn't they all be converging onto a certain point? I know sometimes I don't know, this is a silly example, but I was, when I was grading AP exams in Kansas City, I remember leaving the convention center and I saw all of these people converging on this one spot. And I'm like, wow, that looks like a really fun concert or something. I could kind of see inside the venue, but you see, it was unusual from the other days where people just walking all over downtown Kansas City as opposed to getting swept up in this convergent series. All right. So convergent means, I think someone in my class actually, do you remember if it was you? You could claim it. Use the word like a funnel, like it's funneling into something. Maybe it wasn't in here. Okay, so anyway, divergent is it's getting bigger and bigger and bigger, and the infinite sum, which is actually just the sum. Just if I just say S and there's no subscript, that means I want the sum of all the terms. And so if it diverges, it does not have a sum. The infinite sum does not exist.
So R is greater.
And so, and that happens if your absolute value of R is greater than 1. It'll just get bigger and bigger and bigger, and you'll never get to add them up. Okay? Surely I've done this before. I hope this isn't your thing on the printer. But anyway, I'm always tempted to read them out loud. So, like, if I cut this in half, which wasn't very good, and I cut that in half, and I tear this 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 in half, and I announced before I started this that I was going to do an infinite geometric series. You'd probably go, stop, we have to do exam review, Miss Lazari, right? Okay, like stop. But look what's already happened in a very few seconds. What's happening to my terms as I cut them in half? So if I wanted to add up all those pieces, I could, couldn't I? Okay, I'd add up the 1/2, the 1/4, the 1/8, the 1/16. Right now, this is what I have so far, okay? And so what are the terms approaching? 0. And so if your terms are getting smaller and smaller and smaller in a geometric, you have an infinite sum. And it converges to S is A sub 1 over 1 minus R. Okay? Because the sum of a geometric series, which kind of bugs me, I still haven't derived this for you, which I love the proof of it, but today you probably don't care about the proof of it. S sub n is equal to A sub 1 times 1 minus R to the n over 1 minus R. It comes from a really cool place, but right now you're just trusting the formula. We've talked about this also, but maybe some of the class didn't grab it. As this number gets bigger, what happens to my ratio? Right, Elena and Katie, it gets smaller and smaller and smaller if the ratio's like Nicole keeps saying, only if the absolute value of the ratio is less than 1. If I have something like 3/2 to the first, 3/2 to the second, 3/2 to the third, 3/2 to the fourth, that's getting bigger and bigger and bigger, isn't it? Okay? So if this is getting smaller and smaller and smaller, what is this approaching? You just saw it with paper. 1/2 to the 10th, 1/2 to the 11th, it's getting closer and closer. This number is getting closer and closer to 0, isn't it?
It's like 1 minus 0.
So it's like 1 minus 0. So it just turns into this formula, which you can't read in red. This part just becomes ridiculous, okay? If I said find the sum of 100 terms, and your first term is 7, and you have 1 minus 1/10 to the 100th power over 1 minus 1/10, what do you think this number is going to get closer and closer to? It's going to get closer and closer to just 1. If you type 7 times 1 minus 1/10 to the 100th power, I actually think your calculator would just say 7. Because it'll get 7.000000000000000 something way down that it's programmed to eventually round it off. Okay?
I did a delta math.
Wait, hang on. Is that okay with everybody? All right, so can somebody tell me in your own words what types of series can converge? By the way, there's there's lots of different series to learn next year. Okay? Right now, all you know is arithmetic and geometric. I won't ask you if the Fibonacci or the well, I can't even think of another series. Taylor series and Maclaurin series. I won't ask you if any of those converge or diverge. It'll only be arithmetic or geometric. Arithmetic will never, ever converge because you're always adding something or you're always subtracting something. But if you're multiplying by something, do you see that can converge? But not if it's getting bigger, then it will diverge. So I'm not going to ask in your own words because I just said it again. Okay, so questions. Lindsay, you had a question?
For the infinite one, is it possible to get a decimal that like goes on for a long time? Like,
For the sum?
Or like, does it have to be a whole number? Like,
Oh, absolutely not. It doesn't have to be a whole number.
Oh.
Like 4/3 is a great sum. That's 1.3 repeating. Repeating, I mean, in the world we live in an honors pre-cal, why don't need whole numbers?
Okay, so
No, something could add up to 1.489.
it could be like a decimal that goes on forever.
Yeah, but if the decimal goes on forever, it can always be written as a fraction. It better be repeating. If it's not repeating, you've done something wrong.
If it's not repeated.
then something's wrong. Because then you haven't found the sum. All right, so on the quiz. All right, so given the series 3 plus 3 over 11 plus 3 over 121 plus 3 over 1331 plus ... what does this mean right here? When we write it, find the sum of 10 terms. I don't know, I'm not going to check right now. Hopefully nobody found all 10 terms and added them up on your calculator. You could do that, but you got to be prepared on the test of, if I say find the sum of the first 100 terms, you don't want to do that. Plus, you might not even make it out okay with just 10. It can be very tedious. Please don't do that, okay? It's geometric. The way to find your common ratio is to divide backwards. And for each one of them, you get 1 over 11. So your ratio is 1 over 11, which would have been, what was that? And you could have used the decimal. What?
0.09.
Oh, yeah, it goes like this, doesn't it, forever?
Yeah.
Okay. All right, so I only want the sum of 10 terms, so I'm going to look at the first term, which is 3, times 1 minus my common ratio, 1/11 to the 10th, over 1 minus 1/11. So I have 3 times whatever 1, this is already going to be close to 1.
It said it was just 3.
It said it was just 3. It already gets really small. And 1 minus 1/11, that'd be 11/11 minus 1. So is that 10/11? And so you basically should have had 3 over 11/10 if that, when you type that into the top, and 33/10. Is that the answer that most of y'all got? Or 3.3?
Yeah.
Okay. Now, the person that added the 3 plus 3/11, hope you aren't sitting in this room, but if you did, I'd have to count it. You should have gotten 3.3, period. Like, that's it. Any questions on number 1? Everybody had the same number 1. Number 2, it's interesting, some people just used the problem it looked like in looking at some of your papers, they just sort of used the problem before it. But, oh, I'm sorry, you are supposed to use a problem before it. That's why I saw it so much. That's a good thing. All right, so use sigma notation 2 different ways to write the sum. All right, so if I start at n as 1 and go to 10, I would start with the first term times 1/11 to the n power. Or you could start wherever you wanted to. I could go from 2 to 12, 1 over 11.
Wouldn't you do n minus 1 for that first?
This one I would do n minus 1, thanks. So this one would have to be n minus 2.
Or you could just start at 0 and do n, right?
You could start at 0, but you'd have to go to 9. You could do that.
So you always want to get like 10 terms, and then it's like just making the first term fit.
Yeah.
And you get like half credit.
Well, that's the purpose of a quiz. To me, that's what we're trying to find when we take a quiz instead of a test. Okay, girls. Any other questions on number 2? All right, number 3, you had 56 plus 56 over root 2 plus 28 plus 28 over root 2. Your ratio was 1 over root 2 if you found that successfully. And it went on forever, and I said find the sum. I mean forever. So I would use this as 56 over 1 minus 1 over root 2. So it's 56 over, you could put it in your calculator. I'm getting root 2 minus 1 over root 2. I would just put that in my calculator. Whoever's I'm holding here tried to do it by hand, which I'll check and see if you got it right. That would be hard to pull off by hand because you would need to multiply by the conjugate. What'd you get, Nicole?
191.196.
191.196. A few of y'all got that?
Yeah.
196?
Yeah, it's like 195 and 95.
All right, let's do it. I've got the calculator up. So, girls, always give 3 decimal places because you'll do that in A, B, or BC almost all the time. Every now and then you have a question that asks you to round it off to something else, but It's almost always, I'm not sure what I'm doing, hang on. Okay, divided by 1 minus, I forgot what I was even doing, sorry. 1 minus 1 over root 2, which is also root 2 over 2. Oh, okay, 191.196, I got you. Or I would take 195 or more. Okay? All right, any questions on that? I think I was saying, wait a minute. Any questions on that? By the way, just an algebra skill I want to talk about here. If you were going to try to give me the exact answer of this, I don't allow complex fractions as a final answer for full credit. And so to get rid of this complex fraction, you would multiply the top by square root of 2, which is kind of an exam review because you have some complex fractions to deal with on the part 2 of the review packet. A complex fraction is something that has a decimal in your fraction or a fraction in your fraction. That just means you're not finished yet. You have to make it either a fraction or a decimal. So this gives me 56 root 2 over square root of 2 minus 1, which I would take that as an answer. If you're trying to get rid of your square root on the bottom, you'd have to multiply by the conjugate. You'd have to multiply by square root of 2 plus 1, square root of 2 plus 1, and you would finally get rid of your square root on the bottom. Because the bottom would give you 2, this would cancel, minus 1. So anyway, I'll check that if you did it by hand. All right, number 4. Write segmentation for a geometric series that converges and one that diverges. That should have been pretty easy if I'd used the words enough for y'all, and then I tried to make sure you knew what was going on. If I say like to the n or k or whatever, and you could have just started wherever you wanted to and made sure you went to infinity. This one is going to converge, and if I did like 4 times 3 to the n, as n goes from 1 to infinity, this one's going to diverge. One thing that I see some kind of confused faces is if this number is not infinity, if that's 705 or 75 or 7, there is a sum. I can say add up 705 terms of anything. That would be extremely large. But you could always add up a certain number of terms in anything, as if they go off to infinity, that where you're worried about convergence and divergence. And I mean, obviously, I'm probably the only one that made up those two. I'll read what you created. Okay? I'm not going to go over the bonus right now. I think it was 4 days or 4 years or something like that. Okay, any questions on the fourth one of something you wrote? You want to see if it was okay? Or comments now that I've gone over that? Clarifying questions?
Seems worse when you're answering.
Okay. Well, I felt like, and hearing y'all, well, I'm not gonna work it right now. I think it was 4 years. Okay, huh?
I said more than 10,000, so I was like, oh, I don't know if 4 years is over 5 years, because I do 5 years.
What was the population at 4 years?
It was 12,000 something.
So that would be 4 years.
Yeah.
Because the formula's giving you the population. I'm just going on what they said, but I think it's 4 years. Okay, let me think. Is there anything else I want to say about this? Because something was flying through my mind. I don't know what it was. Okay. All right. So now, get my. I thought I had my review up here.
Can I ask you a specific question?
Yes, we're about to do that.
Oh, sorry.
Okay. So now, specific questions. So just tell us what section you're on, part 1 or part 2. And I'm going to start with Nicole because she's been ready, and then I'll go around. All right?
Mine wasn't a review, it was from an old test.
Okay.
It was, I can show you. It was like
Alright.
a graph, and then it was like
Which number?
number, this one. It says to
Okay.
put it in sine, cosine.
So this is on trigonometric graphing, and it went up to 2. All right, it looks like this. And why Mr. Hill and I ask so often you to write your own equation is because it really shows a lot more understanding than us giving you an equation to graph. So on this part of the test, and I would easily, if y'all ask me a question, I'm like, oh, I wouldn't ask that on the exam. We'll just do something else. I would certainly ask this. If you know how to do your trig graph, you should be able to draw a graph or me draw a graph and you pick it out for multiple choice or matching or write your own or whatever, okay? Oh, I'll send out the format of the test. I don't think I did that over the weekend, but I don't really know why we're doing that. But anyway, I told my husband, he was like, what? He's like, my teachers never told me there were like 15 true, false, and 25 blind. He's like, what are you doing? I'm like, no. Anyway, I'll send out the format of the test so that you know what it's like. You will have, the first page or two will be non-calculator, so be careful with your packet. We hadn't quite worked out how we're going to make that happen yet, but there has to be a non-calculator part, so we can ask things like sine of 3 pi over 4 without you typing it into your
Like
calculator.
memo quiz stuff.
Yes. On your note card, remember you cannot put anything like the 1, 2, 3 chart, all students take calculus, your unit circle stuff. Once you get your test, you can write whatever you want to on it. So your note card can have like identities. It can have some things off your memo page like formulas, area of triangle, identities, SOHCAHTOA, sine is x over r. It's not really. Cosine's x over r, sine is y over r. So let me work this problem, then I'll take other questions. All right, so it said to write it in two different ways, similar to what you just had. And so in terms of sine and in terms of cosine. A was the sine one and B was the cosine one. And so for cosine, it was super easy to graph because to me it looks like a cosine wave. Do y'all see what I mean? So the amplitude is 2. It looks like a positive cosine wave. And I need to force the period to finish by pi over 2. So I'm going to say 2 pi over what would force it to end at pi over 2. Do we do 2 pi over b in this class or 2 pi over c? Okay. Sorry, different years I do different things. So this would give me 2 pi equals b pi. And so you can clearly see that b would have to be 2.
Or 4.
I'm sorry, what have I done wrong? Oh, that's 4. So you can clearly see that b would have to be 4. So if you divide by pi, thanks, b is 4. All right, so that gets you that cosine graph. A sine graph, you've got to figure out your phase shift. So sine, I probably would pick it up right here, just so I could do a positive sign. I had to read what you wrote. You could have done a negative sign. Sorry, I don't know what I'm stuck on here. All right, so I'm going to back it up and have a phase shift. Sorry, this is not cooperating. I'm going to back it up and do a phase shift. I don't know why it's not responding. There, finally. I'm going to back it up and do a phase shift of negative pi over 4. Because this, you could see on your graph, was negative pi over 2. And so now I know that the period is 4. And I've got to make my phase shift 4x minus something equals 0. 4x equals c. X equals c over 4. I want my phase shift to be negative pi over 4. And so you want to force that to happen. So c would be negative pi, be positive pi. So when you cross multiply, you get 4c equals negative 4 pi. You have to be careful here, Nicole, or anybody else that's listening. C is negative pi. I think in your formula you had maybe cx minus d. So to put it in, you have minus and negative. But just double check. Just stop and look at it and make sure it's going to back up pi over 4. You can always change your sign if it's not exactly what you want. Something's wrong here, though, or else I didn't count off on your paper. You got 4x plus pi over 2, and I got 4x plus pi. Maybe I'm not reading maybe I just can't see the numbers. Oh, I'm sorry. Pause, girls. I couldn't see the numbers very well because it's been written on. So not her fault. She was just getting common denominators. Let me blow this up so that I'm not confusing you on this. The period was pi over 2. Here, Nicole. the version, I'm sorry, her test has been written on, so I can't really see the numbers. That's pi over 4, so do you see that would be pi over 8? And so I did that wrong because I couldn't see it very well. This is negative pi over 8, not negative pi over 4. I'm going to fix it. So this should be negative pi over 8. So this should be 8c equals negative 4 pi. Divide by 8. And you get c is negative pi over 2. So this should be plus pi over 2. I'm sorry, that was just a factor of I couldn't read it very well on that graph.
So you know the period is like.
You knew the period was pi over 2. So you've got to fix it for 2 pi over something to be pi over 2.
2 pi over
2 pi over something has to come out pi over 2. Right,
And then the phase shift has to equal 0, right?
right,
So that's why you do the 4x minus c equals 0.
right.
Or, well, yeah, this would still be 4x minus c.
And guess and check also is not bad because you do it with great intelligence. So, I mean, it's all right if you try to make your phase shift be negative pi over 8 by thinking about what number it would be without doing the algebra. The algebra is just going to get you there super fast right away.
Okay.
Okay, any other questions on this? Sorry about that, I messed that up. Okay, Lily.
I was just wondering if we could do like one of the solving trig function.
Yeah, you might need your calculator for some of those depending on if it won't factor. So do you have a certain one?
3.
All right, this is number 3 on solving trig equations.
Or any one of those. I don't know if it wants one. I'm kind of confused.
I'm still looking for it. Here, let me, do you have yours out? Just, what's number?
3 sine 3x minus sine x
Is it 3 sine cubed?
cubed x, yes.
3 sine cubed x.
Minus sine x equals 1.
Okay. So listen carefully. A really, really good mathematician knows whether to sit around and try to do this by hand with factoring or whether it's time to grab a different tool. That's what makes you really, really good. And that's why we use our calculators in this class. It would, to me, be like if you were in a shop class, if you even know what that is, where you have hands-on, like you're building something. And you came in and all I taught you to do was glue something together, or all I taught you was how to hammer. I need to teach you how to use some other tools, right? And you need to know, like, oh, this hammer's not going to work here. I need a screwdriver. I mean, you could give me a hammer and I could go try to fix things around the building, but that wouldn't be very good if I didn't know how to use the other tools and when. When I look at that, I pretty quickly realize I can't factor it. If you can't factor it, probably nobody can factor it because you're the best of the best. So then get out your, you got it now, all of a sudden you go, boy, I really better know my pre-calc if I'm going to use this on my calculator. No. If you take out sine,
You have to make the other side equal to 0.
yeah, that only works if it's equal to 0, Rebecca.
Can you solve it for like 1?
No, because if one is 1
No.
and the other one isn't, then it's
Right.
not.
Like, I meant like, could you solve it for like, oh, that makes sense. I got maybe.
All right, so Nicole answered your question? Hey girls, let's don't talk to each other right now. You can study together later. I know that you're not like being bad, but it's just real confusing to some people if you're talking over them. And all of these are such great questions that we talked about in depth a while ago. So pause for a minute. It is never okay to factor unless it's equal to 0. There are times I've probably done it, but right now you don't know what to do, okay? Do not do that. There's no teacher that ever taught you to factor and set both your factors equal to whatever's on the other side. As Nicole said, it only works with 0. In fact, you're guaranteed to miss this problem, okay? If you set that equal to 1 and that equal to 1. Like, for instance, if I have this times this equals 4, do y'all realize there's an infinite amount of things, listen girls, that can equal 4? I could do 1/2 of 8. I could do 4 times 1. I could do 1 times 4. I mean, I could do square root of things times square root of things, fractions. And by the way, look at this. If you set this factor equal to 4 and this factor equal to 4, you're guaranteed to miss the problem. You just lost. Because if this one's 4 and that one's 4, you just made it 16. Do y'all see what I mean? But what if your teacher in algebra taught you to factor and set your factors equal to 0? This is why they did it. It's called the zero product property. If you didn't dawn on me at your age until I was in pre-calc. If this is equal to 0, then one of these is definitely what? 0. Either you could make that one 0 or that one 0. It only works with 0. Okay? So don't do this. All right. Now, I'm going to say 3 sine cubed x minus sine x minus 1 equals 0. I am in a minute going to go to my calculator because there's nothing I can do to factor this. Okay? There's a few cubes I can factor, but not this one. So you should sit there and go, well, if I can use my calculator. Now, you know the answer as long as my arm is to why you got to learn to do it by hand. But the quickest answer is a long-time mathematician, is if I can factor it and do it by hand, I don't want to pick up my calculator. I can be done by the time I type the silly thing into y equals, wait for it to graph, figure out my window, think about what mode I'm in. Meanwhile, if people have factored and gotten answers, they're 3 problems down the road. Do you see how I'd rather do it by hand? So you do it by hand if it's the most efficient tool. Okay? I could have factored this and been done with it a long time ago if it would have factored and saved us all this discussion. Like the one I'm going to do after this. This one I'll make a quick decision. The hammer's not the right tool. Okay? So I'm going to pick up my calculator. I'm going to look at the directions. And they say from 0 to 2 pi? All right. So I'm going to check my mode. I'm in radians. My premise has always been that this makes you have to know your pre-cal stronger, not less. No one's going to be saved by their calculator on this exam, okay? Window 0 to 2 pi because it said so. And when you're all in AP, whatever you're going to take, it'll usually give you a window. I'm going to be looking for the zeros, so I usually just like squeeze it in a bit. Do y'all see why? I don't really want to look from -10 to 10. I want to see if I see any zeros. Did I ever type it into the equation? It's real important that you type it in. Also, the other important thing is that you change the equation that was typed in before. Sometimes I forget to ever even go to a new problem. All right, so 3 parentheses sine x cubed. You've got to cube the whole thing. What's the rest of it? Minus sine x. And then did I subtract 1?
Yeah.
Equals 0. You'll be doing this lots in AP. So I see 2 zeros. And I'm going to go second calc what?
2.
Second calc 0. I'm going to go find this first one. So I've got to meander over here. Go to the left of it. Enter. Go to the right of it. Enter. Enter. And then you have to go to second calc 0 and do it again. There's a few of them on that page that are calculator active. You can tell if I gave decimals. That means your only hope to solve that one is with your calculator. Another thing I want to say, as you're packing up and leaving, there's one. What's the right next one, Lily? What's right under that?
Cosine x tan x minus cosine x equals 0.
Don't ever move cosine, girls. Don't ever divide by variable expression. If you can divide by it, what could you always have done instead? Factor it out. Cosine x times tan x minus 1. Did y'all see I would continue by hand on this one because it's so easy. It's the right tool to use. Okay? It'd be more frustrating to use your calculator. One more thing, there are a lot of hands up. So if you send me a question that I feel like is a good one for me to write out for everybody, you might start getting little videos of number whatever. You can watch them or not watch them, okay? So feel free to do that. That way you still have me to personally answer your question. Bombard me with questions. But it's also welcome to come by. Okay, okay. Will you send that? Yeah. Or did you get that?
No. Is this flashcard like anything?
Oh yeah.
We have a meeting, but I'll be here after the meeting after